Hi, I'm joined by Danny Lohan. Danny is a graduate student here at the University of Illinois and was one of the first gurus when we founded the Illinois Maker Lab back in 2013. And Danny knows more about 3D printing than just about anybody that I know. So I thought he'd be a great ambassador in terms of showing us how to turn your ideas into objects. I'm going to go through 3 steps. First of all, how to take an idea and create it using a 3D modeling program. In this case, Danny will be demonstrating very quickly a program called Fusion 360.
That's right.
Second, how to prepare that digital file for printing on a 3D printer. Then finally, how to actually take that file, put it on a printer, and come out with a finished object. So Danny, what are you going to show us how to make today?
Well, today I think we will go through making a jet airplane. And the reason I chose this object is because the software Fusion 360 makes it really easy to model parts such as this.
So Danny, what's the first step in this process? How do you go from an idea to an object like this?
So the first step is to choose the appropriate software. And as I mentioned, today we're going to use Fusion 360.
Okay. And Fusion 360 is an Autodesk product, correct?
That's right.
And it's one of the most advanced modeling programs out there.
That's right.
And we're actually, if you stick around with the rest of the specialization, in the software portion, the software course of our 3D printing specialization, we actually get a hands-on instruction by Jeff Smith, who works for Autodesk and is a Fusion 360 ambassador. And you should be able to, by the end of that course, learn how to make things like this, right, Danny?
That's right.
Right. So go ahead and take us through the steps.
Sure. So the first thing we're going to have to do is open the software package. So this is the icon for Fusion 360.
Okay.
If we click on that, it'll start opening the software. Now what's unique to this software is it's actually cloud-based.
What does that mean?
That means you'll need some internet connection to log into the software, and through that connection and your account, all your part files will be saved online.
And are there advantages to being online? So could you share your files with people working in other parts of the world?
That's right. So Fusion 360 makes it really easy to collaborate with people around the world or locally when working on a part file.
Okay. Okay, now what do we have here, Dan? Looks like we have almost like a topographical map without anything on it.
So this is the user interface for Fusion 360. The reason I'm using Fusion 360 to design this airplane is that Fusion 360 doesn't work like traditional CAD programs where you have parametric modeling. It actually uses something called T-splines. You can think about it like sculpting. So we can start with a block of material, say clay, and we can pull and morph it until we get a shape like the airplane in just a few minutes. So I'll show you a quick example. If we create this, this tool, we enter the form environment. And in the form environment, we can input objects and modify those, basically free form. So here we have an object. One thing you would need to do is define how many faces and edges are in this part. So you can do that with the dialog box presented.
And what's a face and what's an edge?
So an edge is represented by the line, and 4 lines connected together usually represent a face. Beyond the creation tool, we can use the modified tool, which has a wide assortment of modifications we can use to change the shape and sculpt this into an airplane. And we can directly pull, push, and modify this object with simple clicks of a button. Once we have our desired faces selected, by clicking the Alt button, we can extrude this face. By selecting one of this outer rim of icons, we can resize the objects or faces. This way we can increase the size of our object by molding it. In order to create the wings, we can select one of the surfaces or more and use the extrude function to pull that surface out, resize it, and reposition it. We can do the same on the other side for the second surface. By doing similar procedures, we can repeat this on all of the surfaces to create different features on the airplane.
So are there any tests in Fusion 360 to let you know that the actual design can be 3D printed?
So what's really nice about Fusion 360 is if you create this whole model in the form environment, it is guaranteed to be watertight and ready for printing. So you do not have to take additional steps like you might with other software to make sure that you can 3D print your part.
Now, what is watertight? What does that mean?
Watertight means that there is a closed surface. So you can imagine dropping this airplane in water. Water would not go inside the airplane.
Okay. And to print an object, it should be watertight, correct?
That's right.
So why don't you go ahead and take us through the steps in terms of moving from this finished 3D model in Fusion 360 to the next step in the process, which is preparing the design file for printing.
So what you would need to do is go into the File menu and click the 3D Print button.
So 3D print menu item.
That's right.
Makes it easy.
And from here we can select the object, make any modifications you might want to it regarding resolution, and output it directly to a STL file.
Okay, now STL is sort of the PDF of 3D printing, right?
That's right.
So other programs besides Fusion 360, such as Tinkercad or Google SketchUp, for example, will also produce STL files.
That's right.
And that's the output. Then you take that STL, and the next step is to prepare that in a 3D, it's called a slicing program,
Right.
which prepares the file for printing.
That's right.
And the reason we do that is because these programs, even though Fusion 360 was sort of designed with 3D printers in mind, but these programs are creating 2D images that are not ready for actual three-dimensional printing. And in essence, what they're lacking is the command instructions that tell the printer, the printhead, where to go.
Right.
How do we take that STL file and put that into the slicing program?
Sure. So each 3D printer comes with its own slicing software. So the Ultimaker specifically uses a software called Cura. And we can open Cura by clicking this icon.
And so you can download Cura for free?
That's right. So slicing is the essential step between your 3D part file and a 3D printed file. And what slicing software does is it takes the part file you have and it will cut it into a large number of layers. So you can imagine taking a slice with a chef's knife of your 3D part. And on each of those layers, it will trace the path that this end effector takes to draw the part on each layer. And by successfully drawing each layer, eventually the printer will print the part. So this is basically making the recipe or cookbook for this particular print file.
Okay, that's a great description.
So we can open the airplane file, and it places it on the build plate. The area on the bottom is called the build plate. And as long as your file fits within these bounds, it should be able to print by the Ultimaker. When the object is imported, it might have the wrong orientation. We can change the orientation by selecting the object and clicking the rotate button. So there's a lot of customization when using Cura. One thing you might note right off the bat is it shows the amount of time it will take to print the part.
Okay.
So what's important here is if you adjust the, say, resolution, make it higher fidelity, it will increase the time. But you can do certain things such as increasing the amount of material inside the part, so adding infill, making it partly hollow, and this will decrease the time it takes to print. So you can adjust the settings based on what you need to get a print that's reasonable in time. So another thing we can do is change the size of the object we want to print. So if you click the object, there's a scale button. Right now we have a 100% scale, so it's 1. If we resize the object to say half scale, we'll notice that the time is significantly reduced for print.
So Danny, while this is working, what are some of the main considerations that someone has to keep in mind when engaged in this slicing process? What are the typical things that are adjusted besides the size of the design? So
the number one thing I would consider is whether or not your product needs support material.
Okay.
For example, this airplane has wings, and you can see that these wings are not touching the plate. So the 3D printer can't print in thin air. In order for it to actually make this part, you have to include some material under it so that it can print on top. And what the printer actually does is instead of creating a solid support structure, it makes a very loosely meshed support structure so that it's easy to peel off.
They just take that off with some pliers or a file.
So in the Basic tab, you can see that there is an option for support type, and you can put support structure wherever you want in whatever form.
Where would you put the supports for something like this?
So for this, I would put supports everywhere, since there are a lot of locations that have some overhang or floating material.
With 3D printing, we can make an object completely solid or completely hollow,
Right.
or anything in between. So you talk a bit about that, that infill.
So since this is a display piece and nothing structural, we can actually remove a lot of the material inside. So inside the basic menu, there's an option for fill density. So right now it starts at 10 for default. So that means 10% of this object will be filled with material.
So 90% of it will be hollow.
That's right. So we can change this setting to speed up or slow down the print depending on what your need is. And as I mentioned, since it's only aesthetic, we can drop this down to 5% and print it that way.
It sounds like the infill consideration is influenced by two factors. One, the amount of time that you have.
Right.
So if you press for time, perhaps you make an object a bit more hollow.
Right.
And second is what you plan to do with the object.
Right.
If it's just sitting on your desktop and people are looking at it, then it can basically be a hollow object.
Right.
Versus if it's a bracket that's holding something heavy, you may want something that's a bit more solid.
That's right.
Inside. Are there other considerations? How about you mentioned the resolution of the print.
Sure. So one way you can change the quality of the print is through the basic menu again. And you have several options, the first of which is the layer height. And that's going to describe the amount the print head moves up between each layer.
Okay.
So if you decrease this height, you'll get a higher resolution on the z-axis.
And what's the typical resolution level?
So that depends on the type of printer.
Well, typically in the Maker Lab, we print most of our objects at a layer height of around 250 microns. What that means is that 4 layers equals 1 millimeter, or in other words, each layer is only a quarter of a millimeter thick. As a point of reference, the width of a sheet of paper is about 100 microns. And the Ultimaker, as well as the MakerBot, will print something as fine as the width of a sheet of paper. But typically, we don't do that because the products that we use look pretty good, actually at 250 microns,
right.
And we don't want to stick around for days to have the object print. Anything else we need to do, Danny, before we actually start the printing process?
No. At this point, we can go ahead and select this button to save the toolpath.
Okay.
And it'll actually save it directly to our SD card, in which case we can use that to print it.
And so it's saved, and you're going to take the card and do what with it?
So once we have the part on the card, we can take it and plug it into the printer,
Okay.
in which case the printer is going to read the part from the card and begin printing.
Okay, so both the Ultimaker as well as the MakerBot both use an SD card.
That's right.
To read the file to print.
That's right.
Okay. And here's our jet airplane. Nice job, Danny.
Thank you.
It looks great.
So what we're going to have to do is remove this airplane from the platform and remove the support material. What we'll have left is just the fighter jet on its own.
Here it is, Danny. What do you think?
I think it looks good.
Great job. Well, Danny just took us through the steps and how you can turn your ideas into objects using 3D printing technology, in this case to make a plastic airplane. In other parts of this course, you'll see lots of other examples of people using this technology to revolutionize the economy, all the way from making 3D printed earbuds to making prosthetics for children around the world. Hope you stick around to see these videos and learn more about this fascinating new technology.